Welcome to Test Automation for Dynamic Content and our Applitools in Action series. I'm Pam Morgan, and I will be today's session host. I'm joined today by my colleague, Talia Malamad, part of the stellar customer success team here at Applitools.
Thank you very much, Pam, and thank you everyone for joining. Thank you for joining the webinar for Test Automation for Dynamic Applications. In today's fast-paced digital world, dynamic applications have become a norm. So how can we possibly ensure that they work flawlessly? So we gathered this webinar for you today to share from the experience that we have with helping customers managing dynamic content and testing it successfully across many accounts and customers that we manage. So let's think about your testing pipeline as an alerting system. It signals issues early, preventing them from reaching production. But like any other faulty alarm, unreliable tests can cause more harm than good. That means that reliability is clearly the key. A reliable test suite provides predictable and consistent behavior. You should be able to trust that a passing test means that your code worked correctly, and a failing test indicates a real problem. If tests are flaky, unpredictable, or inform you of false positives, teams may ignore tests, defeating the purpose of having the test in the first place. And the time that's spent investigating false alarms or inconsistent test results is better spent on actual development or on bug fixing. So the conclusion here is clear. If your tests are not reliable, you might be better off without them. A reliable test suite is essential for maintaining confidence in your code base and also catching issues before they escalate. Now let's look at the testing pyramid. The higher we get into the testing pyramid, the harder it is to maintain a predictable behavior. The higher we go in the testing pyramid, the more difficult it is to build and maintain stable tests because the test scope broadens and it becomes more complex to isolate specific components and features or to use mock data. That's leading us to a high risk of false positives. The lower we get in the test automation pyramid, the easier it is to build more granular components with much higher testing stability and much higher predictability. And the more dynamic the application is, the challenge increases. Higher level tests may require more frequent updates and to keep pace with the UI changes. And there are frequently UI changes. So the purpose of today's webinar is to dive deeper into addressing this unpredictability. We'll be reviewing different ways, tools, and different techniques to overcome unpredictable factors in test automation, with factors that have a big impact, especially when the application is so dynamic by nature and the application that includes quite a lot of dynamic content. We'll be reviewing different dynamic use cases, dynamic factors, and also offer solutions customized to each one of the factors to find the predictability in highly dynamic environments. So today we'll be focusing on three main factors that may create some unpredictable behavior of the app. The first one is dynamic DOM structure. Broken locators are a significant weakness in writing stable tests because they can lead to flaky or unreliable test results. Also, another factor is the test environment. These days, dynamic applications and applications in general are required to support the different browsers, device, and screen size validations. This might lead to rendering issues, unexpected UI issues, and also elements that are not scaling properly, overriding other elements and creating alignment issues and also distorted elements. Last but not least is that by nature, the modern application includes a lot of dynamic content. The dynamic content can result from either supporting multiple languages or validating different user input variations. that lead to changes in the behavior of the app. We also be looking today into supporting different user profiles that may create a different testing flow per user, and also how we can support the application when we need to integrate with external tools, such as supporting application that includes advertisements, widgets, and also banners. So all these factors can decrease the predictability of the app. So how can we build an environment that can create a predictable testing environment when we have all these different factors? We have here the code base, the environment base, and also the nature behavior of the app that includes dynamic content. So let's see how we can resolve all these issues. All right, so to deal with the broken locators, when a locator changes due to modifications of the app, the UI of the app, the test can fail unexpectedly, even if the underlying functionality remains correct. Also, updates of manual locators can be prone to errors, leading to additional test failure. To overcome the unpredictability of the code base when writing the test, we in Applitools here, we developed the execution cloud to reliably identify UI elements. So Applitools, as you all know, is a true believer in AI. And as such, we built the first AI Selenium grid that learns your application from each interaction. And this way, if a selector in use gets broken for any reason at all, an alternative locator will be in use in runtime to ensure smooth execution of your tests. The execution cloud overcomes the issue that's created when having dynamically generated elements or changing locators and addressing the problem of poorly chosen locators. You can see here that once the execution cloud with self-healing capability is enabled, you'll be able to see the name of the original locator and also the fixed one in your Applitools dashboard. Now let's proceed to facing the second dynamic factor that we talked about, which is how we can run cross-browser testing and support cross-device testing and still remain and increase the predictability of the app. So to mitigate the inconsistent rendering of cross-browser and cross-device testing, Applitools developed the ultra-fast grid. So the ultra-fast grid enables our customers to run tests across different browsers and viewport-sized combinations. And what makes the ultra-fast grid so unique is that it enables you to run your tests across all these different variations of browsers, mobile devices, and screen sizes based on a single run. And the way it works behind the scenes, the architecture of the ultra-fast grid enables you to run your tests based on this single run, since during this single run, Applitools captures a snapshot of the DOM, and we then render it in parallel for you across all the different and required combinations. Now, this solution enables you to increase your testing stability simply because we run the test only once, so we can reduce the flakiness that would have caused if we had to run the test so many times. We also increase the efficiency since the rendering here is done in parallel, so it takes nearly no time, no additional time to add additional environments, and the time that it takes to run a single test can also help us generate all this wide coverage. So it helps us reduce the execution time and get faster feedback as we get all these details of all the tests that rendered in parallel. Now, it's important to emphasize that behind the scenes, the functionality of each testing and browser engine remains the same. So in order to get wide scope and wide coverage, all we need to do to increase the predictability of the app and get wide coverage across different browsers is to render the tests across the relevant variations. And now let's focus on the third factor that creates some flakiness, might create flakiness in running our tests. And this is the content of highly dynamic applications. So in Applitools, when we run a test, we compare a baseline image that represents the expected behavior of the app. We compare it against the equivalent checkpoint image. The checkpoint image represents the way that the application looks like at the moment of running the test. Now, the question is how we can create a baseline. How can we present an expected behavior if the behavior is constantly changing? Let's have a quick look into this example. Over here, you can see that we ran a test that includes dynamic content. The icons of the baseline change, the text change. So entirely the entire page includes dynamic content. Now, for this purpose of validating application that includes dynamic content, Applitools developed the layout matching algorithm. So the layout matching algorithm is designed to deal with use cases where we have fixed structure, but the data constantly changes. So the layout validates the structure of the test, reviewing the structure, checking if there are any missing elements, and also identify different broken structure. And layout by design, it overlooks the actual content. So with the layout matching algorithm, we are able to validate dynamic contents pretty easily. And this is very typical for use case of having a date field, dynamic ID number, and email address. These are very commonly used fields among our customers. And the layout region can be applied either on the entire page, as we've seen in the previous example, or it can be applied on specific regions. And applying the layout as a region on the test can be applied either directly from the code or pretty straightforward directly from the dashboard. And in case we run a test build that includes quite a lot of visual comparisons, and if we want to apply the layout region on a broad scope, we can apply the auto maintenance capability that enables us to manage and apply the regions automatically on the scope of the entire build. All right. Now, when we are familiar with the layout region, we can then look into an additional very common use case among our customers, which is the localization testing. Very frequently, our customers are required to support their application across different languages. It can be over 20, 30 different languages. And in Applitools, we have unique best practices that can help you address this testing use case. So first, what we can do is to maintain a baseline. As we mentioned, the baseline represents the expected behavior. So we can maintain a single baseline for all the languages that look pretty much alike. So all the languages that go from left to right can have a single baseline image. And this allows us to compare the baseline image, as we mentioned, with the expected behavior against the application as it appears in the checkpoint image and how it's presented while running the test. So with this approach, we can reduce the number of baselines that we can maintain, and we can get value from validating the structure of the page of each one of the languages. Another best practice that's even more recommended is to actually maintain a baseline, a predictable behavior per language. With Applitools, it's extremely easy to create a baseline per language, simply because each time when you run the test, a new baseline is being created for you. So with Applitools, it's easy to run the test across different languages, and automatically a baseline will be created per language to define the predictable behavior per language. There are other ways that we can design the baseline and increase testing stability and reliability with Applitools algorithms. We have the floating region. In case you would like to include movement tolerance of our application of a particular element, we can define with the floating region the boundary of an element. As long as the element appears within the boundaries that we defined with a floating region, then Applitools will not mark it as a UI difference for you. For example, here, if we have this element, the logo that shifts, as long as it remains within the boundaries of the floating region, the blue area, Applitools will consider this as an expected behavior. But if there are any changes in the font, the color, the size, this will be flagged as a difference. Lastly, we also have the ignore colors matching algorithm that can be applied as particular regions in case you have an element that frequently changes its color and you would like to overlook this type of dynamic behavior. So overall, the main key point to take from here is that we want to create a baseline that will represent the application of our app as accurately as possible. We have all these different tools in Applitools, different regions, and unique algorithms that can help us design the baseline in a way that will give us the accurate and most reliable test results. Another very frequent use case that we see among our customers is the behavior of the app, dynamic app that changes based on a user type. So let's say that I want to run test and validate an app when I log in as an admin, as a student, or as a manager. Each time when I change the user type, the entire app flow changes. So for this purpose, we highly recommend to create a baseline per user type, and this can be easily managed with Applitools baselines. The way baselines are being created, as we mentioned, very straightforward and easy to implement. And in case there are different UI differences that we detect, we can manage it automatically in a wider scope with the auto maintenance capability. So we can help you reduce the maintenance time, and we can help you consume the test results in an automated way. Now let's have a look into another use case when we have dynamic structure, and while running the test, we are unable to predict which behavior of the app would appear. But we do know that in this use case, we have finite number of options. For example, I might run an app and I have an inconsistent behavior of a banner or a widget, or if I apply the search functionality and I can get 1, 2, or 3 different items as a search result. So we have here finite number of options, and we can apply Applitools multi-baseline variations capability in order to create a single baseline that supports more than one behavior. So we can support up to 20 or more different behaviors under one single baseline. So while running the test, the checkpoint image that we capture and that represents the expected behavior can be compared against any of this predictable behavior that represented with the baseline variations. Now we gradually increased the level of unpredictability in the app, and the real challenge is how we can deal with an application that is highly dynamic and has infinite number of options that can appear. So how we can build a test that's reliable, that's stable, when we have so many dynamic factors under one screen. So you must all be familiar with this page. Each time when we apply a different search, we can get a different behavior of the app, clearly. So in this particular use case, when we have infinite number of combinations, we highly recommend to break down the page into smaller pieces. Each piece, each part of the test can be as a standalone baseline, and any of the best practices that we covered up until now, any of the algorithms that we can apply, can be added to any of these baselines. So if we dive deeper into this particular example, we can break down the page into the header, the navigation bar can also be a standalone baseline, and the body can also represents the body behavior with a standalone baseline. So in other words, we always look for predictability even in a world or an app that is completely unpredictable. All right, so to summarize, we covered the goal of creating a predictable and reliable and stable testing pipeline, and we covered the different challenges. We have factors in the code, in the environment, and also in the content that creates an application that's very hard to maintain unless you have the right tools, techniques, and algorithms. We looked and addressed the different challenges with different solutions. We talked about infrastructural tools, the execution cloud, and the ultra-fast grid to deal with broken locators, and also to address cross-browser testing and cross-viewport size testing. We also talked about a code-based solution. We talked about the layout matching algorithm and additional capabilities that can help stabilize the test results and create robust baseline that's aligned with the behavior of the app. And we also talked about creating and adjusting the design of the test to make sure the test is robust, breaking down the test into smaller pieces, or also create multi-baseline variations that can support more than one behavior. And our suggestion to each one of you who run tests and try to validate dynamic application is to first categorize the use case that you are looking to validate, whether there's a fixed structure or whether there's dynamic content or the combination of both. Perhaps the structure is dynamic and the content has finite number of options, then we can adjust particular best practices as we covered today. So first identify the use case, the category that it belongs to, and then align the solution accordingly based on any one of the tools here that we covered today. Thank you very much. I hope you found it helpful. And if there are any questions, we would love to help.
Right. Thank you so much, Talia. While people are getting their questions in, I did want to bring up the polls. There were a couple of polls on the poll tab. I'm going to share those with the group now. Let's see. Let me get this to show on stage. So we asked the audience what are the most common dynamic application use cases that you face in your current project. We had some responses on browser compatibility, a lot of concern about dynamic DOM elements, user input variations. I see a few people answering now. And then we had another poll about which of the Applitools capabilities do you use on a regular basis? We see some people using the A/B test, multi-baseline variations, branches and Git integrations, root cause analysis, and reporting. And it looks like we've got a couple of people here who are not yet Applitools users. So I want to point out that if you're not yet an Applitools user, you and your team can try it with a free trial. There is a little blurb at the bottom and also on the resources tab where you can sign up for a free trial. All right, Talia, we have one question that Sharon answered about the reliability of the self-healing selectors. That was in, Marius asked that before. And then it looks like we have another question about What about dynamic content such as tables and graphs? Can you talk about dynamic content like tables and graphs?
Yeah, sure. So with regards to tables and graphs, the question is, first of all, is how frequently the data changes. If it's a matter of not frequent changes or very slight changes, we can apply the layout matching algorithm. For example, if you would like to apply it on a bar chart or a pie chart, so the layout matching algorithm can tolerate some sort of dynamic on these elements as well. If it's a completely different bar chart, we can look into other solutions. As we mentioned, the baseline represents an expected behavior, and Applitools always compares against the baseline. So we do need to have some sort of certainty derived by users and defined by the baseline. And we can tolerate modifications with the layout matching algorithms, including graphs and bar charts.
Excellent, excellent. And if someone has questions about how to do that, how do they get help with that?
They can contact the customer success team. I also added here resources for the tutorial, but we'll be very happy to help in the customer success team, walk you step by step with that. But in terms of the implementation, it's pretty straightforward to apply the coded layout regions, either directly from the code, where you have your test dependencies and where you implemented Applitools, or we can apply the layout from the dashboard itself, and drawing a layout region in the test editor.
Got one other question, Talia. How do you handle a page with a mix of dynamic and static content?
Oh, brilliant question. Yes, so in Applitools, we have different matching algorithms that you can apply in order to validate your page. The default matching algorithm is called strict, and what makes it so unique, can I still share my screen, Pam, or?
Yes.
All right. Are you able to see my screen?
We can see the presentation.
Oh.
Yes. We should be able to go back.
Okay, I can explain that basically in Applitools, we have different matching algorithms. So we can, the default matching algorithm is actually called strict. By design, strict flags all the differences that a human eye can notice. So when we run a visual comparison with Applitools, when we run a test, we actually flag all the differences that a human eye can notice, because strict is the default matching algorithm. On top of strict, we very highly recommend to add the layout regions. So this is one of the most commonly used best practice in Applitools, to base your tests on strict in order to be notified on any UI difference that appears in your app, difference between the baseline and the checkpoint image, and apply the layout on dynamic content in order to reduce noise and only get flags on differences that you care about. I hope I answered the question.
Okay. Yes, I think so. I do want to thank everyone for joining us today, and thank you, Talia, for an excellent demonstration. We hope you found today's session insightful. There's much more to uncover, and our next session, Advanced Debugging Techniques, is on September 19th. We'll guide you through techniques that leverage advanced AI tools to identify a bug's root cause, heal a test, and minimize maintenance workload. There's a link on the resources tab for you to sign up for that if you're not already signed up. As a pioneer and leader in AI-powered automated testing for the enterprise, Applitools aims to make intelligent solutions accessible to all and to deliver unparalleled business value for our customers around the globe. If you're already using Applitools, reach out to your account team to learn more about how you can take advantage of some of these strategies outlined today. And if you're not yet an Applitools customer, you can see firsthand the power of leveraging AI in every stage of the testing lifecycle by signing up for a free trial. Again, thank you so much for joining us. We hope to see you again soon.
Thank you.